are continuing on page 78, and we're looking at the bottom section that talks about converting percentages to decimals. Let's look at the rule first. The rule says to convert a percentage to decimal, remove the percentage sign and then divide the number by 100. So they have some examples here, and we'll look at those examples now. Example A, we have 12%. So we will remove the percent sign, so we'll have 12, and then we're going to divide that number by 100. So this will be 12 over 100. And 12 over 100 is the same as 12 divided by 100. When we're dividing by 100, we look at the number of zeros we have. So that will be 2. So we need to move 2 digits. We have the decimal point there, but we have nothing behind the decimal point, so there's nothing there to show for it. So we would move two things over the point. All right, we'll put them there. So in this place, we put 0. We'll have our decimal point, and we would have the 1 and 2. So our answer in this case would be what? 0.12. Let's go over that again. The rule says we need to remove the percentage sign. We have done that, and divide by 100. This, as a fraction, 12 over 100, is the same as saying 12 here divided by 100. Since when we're dividing by powers of 10, since we have 2 zeros there, we will move 2 digits to the right of the decimal point. So here we'll move our what? 1 and our 2, and we will move it to the right of the decimal point. So when we take these over, on the left where the 12 was before, we have a placeholder, and to the right of the decimal point we put our 1 and our 2. So our answer, as seen in the textbook, for example A, is 0.12. So 12% as a decimal is 0.12. Example B, 6.5% as a decimal. So we'll remove our percent sign, and we will have 6.5 what divided by 100. So this will be the same as 6.5 divided by 100. So we need to move how many? 2 things over the decimal point. We have only 1 here, so we will do what? Add another. We'll add another. Then, so we add a 0 there. Then we'll take these 2 and we will move them over the decimal point. Okay, so right where we have these things that we have moved, we'll put a placeholder. We'll maintain our decimal point. They are going to be in front of the 5 now, so they will be what? 0.65. So our answer for 6.5% as a decimal will be 0.065. Example C, we have 125%, and step 1, we will remove the percent sign. The 125 is now placed over 100, which is the same as saying 125 divided by 100. We have 2 places here, so we are going to move 2 places or 2 digits over or to the right of the decimal point. So when we remove the 2 and 5 and we put them over here, we would have what? 2. We'll have our decimal point remaining. We will have 2 and 5 over that side, and what would be left here? The 1. So our answer for example C will be 1.25. Example D, 2 and 1/5% change to a decimal. First, we need to change our mixed number to an improper fraction. We do that by multiplying the denominator with the whole number and adding the numerator. So we would have 2 times 5, or 5 times 2, 10, plus 1, 11. So we have 11 over 5. Then we're going to be dividing this by 100. Let's make this a fraction by putting it over 1. Earlier when we did division of fractions, we said that we need to find the multiplicative inverse of the divisor, or find the reciprocal of the divisor. So here we have 11 over 5 multiplied by 1 over 100. Numerator by numerator, we have 11. Denominator by denominator, 5 times 100 will give us 500. So this is the same, this 11 over 500 is the same as saying 500 on the outside and 11 on the inside. So we have our dividend being 11 and our divisor being 500. Now let's divide. Can 500 go into 11? No, it can't. So to continue, we'll put a decimal point after the 11. We'll add a 0 where the 11 is because it can't go there. To continue, we're going to add a 0, and this is now 500 into 110. Can that work? No, it can't work. So let's add a 0 here, and we add another 0 to continue. Can 500 go into 1100? Yes, it can go. It can go 2 whole times, because 2 sets of 500 will give me 1,000, and we subtract. When we subtract, we have 1,100 things, and I take away 1,000. I will only have 100 things left. Can 500 go into 100? No. So we will add another 0 to continue. We have 1,000. Can 500 go into 1,000? Yes, it could go in there. And notice I'm lining things up just like with addition and subtraction, column under column, right? So we have 2 by 500 giving me 1,000, and 1,000 from 1,000, and we're done. So our answer for example D will be 0.022 as shown in the book. Just to review long division, first we estimate, then we what? Divide, we multiply, we subtract, and bring down. In class, we made our own mnemonic for this. We said that every dog must swim back. Okay, so we estimate, we divide, we multiply, we subtract, and we bring down. Let's look at example D again, but using a shorter approach this time. We have 2 and 1/5%. We're going to, of course, change our mixed number to an improper fraction, and we know that already is 11 over 5. 11 over 5 should be divided by what? 100. Okay, so 11 over 5, and we're bracketing it so we can see clearly, divided by 100. Let's work out what 11 over 5 is as a decimal first. Okay, so we set this out, and we're going to say 5 into 11. Okay, or numerator goes inside or denominator goes outside, or numerator is our dividend and our denominator is our divisor. So 5 could go into 11. Of course, we would be saying, can 5 go into 1? No, it can't, so we move on. Can 5 go into 11? Yes, it could, because 5 twos would make 10, 5 threes would make 15, 15 would be too much, so we would say 5 twos would make 10. So multiply 2 fives, 10. Then we subtract. We have 1 left. 5 cannot go into 1, so we'd add a decimal point and we would add 0 to continue. So can 5 go into 10? Yes, it could go 2 whole times as before, and 2 fives would give us 10, subtract, and we're done. So for this section, for the top section, our decimal here would be what? 2.2 over 100. So let's set this out now. 2.2 over 100 is the same as 2.2 divided by 100. Okay, now here we're being asked to move 2 digits. We only have 1, so we'll add a 0 there to occupy that space, and now we will move these 2 and we'll move them to the right of the decimal point. So we'll put them right there. Let's see what we'll have. We'll put a 0 here to hold the space point. These two things come over first, so they go 0, 2, and we had 2 there. Let's maintain the place. So we have 0.022. Now that is the same as the answer we got here, 0.022. So whichever approach you use, whether you use this approach or the shorter approach as shown here, you will get the same 0.022. However, let's take note of what happens. In this approach, I deal with larger numbers. The largest number here I'm dealing with is 1100. In this approach, approach 2, the largest number I am dealing with is 11. Okay, so any way you want to do it, it's okay as long as you follow the steps and you get the correct answer. Now we move on to the exercise. It's exercise 4 and it says write the following as decimals. Number 1, we have 20%. Rule, what we're going to remove the percentage, move that sign, and put our number over 100. This would be the same as 20 what divided by 100. We need to move two things over the decimal point. There'd be a decimal point here, and we need to move these two things to the right of the decimal point. Let's put a 0 to hold the space here, okay, and we put these two things over the decimal point. So our answer for number 1 is 0.20. So 20% as a decimal is 0.20. Number 2. Number 2 says 44%. 44, we'll remove our percentage sign and we'll put 44 over 100, which is the same as 44 divided by 100. We need to move two digits to the right of the decimal point. 44 would have a decimal point here, but it's not being shown because we have no decimal to show. So we need to move two things over to the right of the decimal point. So we'll move these two digits and they will go to the right of the decimal point. we'll put a placeholder here, keep our decimal point, and move 4 and 4 over. So our answer for number 2, 44% as a decimal will be 0.44. Number 3, 52% as a decimal. We remove our percentage sign. We'll put our number over 100. So 52 over 100 is the same as 52 divided by 100. We will need to move 2 digits to the right of the decimal point. For 52, 52 is a whole number with no decimal. If we had a decimal point, it would be right there to show. This would be what, $52, no cents, right? That's how it would look. So if this is $52, our decimal point would be right here. So we need to move 2 digits to the right. So we will move these 2 digits to the right of the decimal point. I will keep the place with a placeholder, and I will have 5 and 2 moving to the right of the decimal point. So 52% as a decimal will be 0.52. Number 4, we have 7.18%, and this would be what? 7.18 over 100, which is the same as 7.18 divided by 100. I need to move 2 things to the right of the decimal point. I have only 1 here, so I will add another digit, and I will move these 2 things now to the right of the point. So these 2 things will go to the right of the point. So keeping the place and keeping the decimal point in the same position, I now put 0.7 before the 1.8. So our answer for number 4, 7.18 as a decimal, 7.18% as a decimal will be 0.0718. Number 5, 8.75% as a decimal. First, we need to change our mixed number to an improper fraction. So we multiply our denominator with our whole number and add our numerator. So 8 times 4, 32. 32 plus 3 would be 35 over 4 divided by 100. Let's work this out first. So we have what? We have 35 inside being divided by 4. 4 could go into 35 how many times? 4 could go in there 8 times, because as we multiplied here, 8 fours would make 32. We subtract, we have a remainder of 3. If we have 35 things and we take out 32, we have 3 left. Can 4 go into 3? No, it can't. We'll add a decimal there and add 0 here. Can 4 go into 30? Yes, it could go in there. It could go in there 7 times. 4 sevens would make 28. Subtract. If I have 30 things and I take from it 28, I'll have 2 things left. We add a 0 so that we can continue. And can 4 go into 20? Yes, it could go in there 5 whole times. And 5 fours or 4 fives would make 20. And our problem would be finished. So for the top section here, which is 35 over 4, that section of our problem can now be written as 8.75 now over 100. So 8.75 over 100 could be written as 8.75 divided by 100, like this. Now, we need to move 2 digits over. We only have 1 to the left, so we're going to add a 0 here so that we'll have the 2 we need, and we're going to move these 2 and put them to the immediate right of the decimal point. So we'll have a 0 here to hold the place. We'll maintain our decimal point in the same position. Now we have what? A 0 and 8, then we have the 7 and 5. So our answer for number 5, 8 and 3/4% as a decimal is going to be 0.0875. Looking at number 5 again using the other approach. Of course, we have our 8 and 3/4%, which when we change our mixed number to an improper fraction, we get 35/4. And the rule says we'll remove this sign and then we'll divide by 100. In order to divide by 100, we will place our 100/1 to make it a fraction. And based on our rules of division for fractions, we'll find the multiplicative inverse. So now we would reduce as best as possible. So here we could use 5. 5 could go into 35 7 times, and 5 could go into 100 20 times. We cannot reduce anymore, so we'll multiply across. 7 times 1 will give us 7 over 4 times 20 will give us 80. So now we have 7 over 80, and we need to find what this is. Okay, so we're going to divide. We're going to put our 7 inside and our 80 outside. Okay, because 7 over 80 is the same as saying 7 divided by 80. Okay, 80 into 7 can't go, so we'll put 0 here. We'll add a decimal point and add a 0 here. 7 into 80 still can't go, so we'll add 0 there. And 80 into 70 still can't go, so we'll add a 0 here. Alright, now we get to 700. 80 can go into 700. How many times could 80 go into 700? Well, we'll estimate. We have 700 here, and 80 can go into 100 at least one time. So we know that it should be able to go in there at least 7 times. So 80 times 7, and when we multiply that, we'll get 560, because 7 times 0 will be 0, and 7 times 8 will be 56. So we know it can go in there at least 7 times. But this is not close enough. Let's try 8. 80 by 8 will give us 800, so we know that that's 640. All right, let's try 80 times 9. 8 times 00, and 8 nines would give us 72, so that would be 720. 720 is more than our 700 here, so we will stick with 8. So it will go in there 8 times, and 8 times 80 will give us what? 640. We subtract, and if I had 700 things and I took 640 things out of it, my answer would be 60. Alright, but let's do this step by step. So 0 from 0, 0. 4 from 0 I can't, so I'll have to borrow from my neighbor, leaving 6 there, and bringing that one set of 10 to the 0 here, one set of 10 over here, and now from the set of 10 I will have 6 left. Can 80 go into 60? No, so I will add a 0. Can 80 go into 600? Um, we had already established that 80 times 8 would give me 640, and that would be too much, so it could go in there how many times? 7 times, right? And that would be 560. So let's extend this and we add 7. So 7 times 80 would be 560. We subtract. If I have 600 things and I take out 560, I'll have 40 left. Again, let's go step by step. 0 from 0, 0. 6 from 0, that can't, so I'll take from my neighbor 1, leaving 5 there, and that set of 10 will come here, and I'll take 6 from 10, leaving 4. Can 80 go into 40? No. So to continue, we'll add a 0. Can 80 go into 400? Yes, it could go into 400. It has to go in there less than 7 times. So 80, 8 and 5 would make 40. So it means that 5 times 80 would make 400. Okay, so if you want to prove it, 80 times 5, 0, 8 fives would give you 40, and that would be 400. Alright, so just from knowing the timetable, I know that 8 fives would be 40, right? So that would be as close as I could get, and in fact it goes in there perfectly. So my answer here would be what? 0.0875, and that is the answer that we got when we did the problem here using a different approach. So either approach will take us to the right answer.